corks. I put a box on that has slightly used corks. If it looks like it's falling apart, throw it away, don't use it. And that's what you would use when you're storing things. Whenever I give you an unknown, I'm going to give you a clean cork on your test tube, so don't put any corks in your test tube. And I'm going to give you 2 other clean corks for things that you haven't analyzed. Once you've analyzed and got the confirmatory precipitate, you don't have to worry about contaminating this anymore. Okay? So, there you can use the older corks to store it. And you always want to store things with corks because the solvents evaporate over time. Now the other precipitate, the white okay. I thought I mixed up my white precipitates, but I put them in the right place. That's the ideal thing with labeling. This, of course, would be what? P3B is what you would put on it. Okay. Or you can just put whatever. Or, as I say, you can make up another system because you have lots of pages. You're writing this sort of table and everything on the right-hand page. If you write lightly in pencil, you can always say test tube A has this, test tube B, and when you get out letters, you start numbers 1, 2, 3, and eventually you get to the next experiment. So you can make up your own system. You don't have to follow my system. The other thing is, people always say, can I buy those little labels and put them on? And you may, but what I've discovered over the years and what people discovered, they put the labels on neatly when they go home Wednesday night or Monday night, and they come back the following lab period, and all the labels are laying on top of the test tube rack because they don't stick to these test tubes too well. I don't know why that is, but well, maybe it's with the people that try that just have bad glue, bad karma, bad luck. Anyhow, what I want to do, I've got the white precipitate colorless solution. I have to check this one for completeness because I don't know whether I added enough sulfuric acid. So I go back to my sulfuric acid. Sometimes a half drop comes out and you don't really get a drop, so you have to add another half drop. Okay, the liquid went into the top, no precipitate form. Okay. So that means I had complete precipitation. So here's my other confirmatory test. Now one of the things when you look at these, the yellow precipitate is about twice the size, not quite twice the size of the white. Usually they form in a 3-to-1 proportion size. So here I might not have divided the sample exactly equally. Okay. Those are my 2 references. Now these are the test tubes I saved. These are the first washing, second washing. The chromate gave me a much bigger precipitate. It was very obvious that I got a precipitate. So what I'm going to do is test these with chromate, and I'll bring the chromate over here and stand in front so you can watch what happens. There's my potassium chromate. And as I say, you don't have to do this. I just did this for a demonstration to show you that hopefully one is going to have a lot of lead left yet, and the next one is not going to have very much at all. Okay, there's the first one. You can see it's cloudy. Here's the second one. It's slightly cloudy, but you can still see through it. Whereas this one, there's enough lead left that it was opaque. Whereas here you can see through it, so that means there was next to no lead. That means my original sample has no lead in it at all. Well, it has some lead, but it's a very low amount of lead. Now I have my precipitate left, which I'm going to go to procedure 4. It's a white precipitate. I'll start my, see if I can wake everything up here. Okay. But what I can confirm right now, and since this was my known, and they look like what I would expect for a medium, this was a yellow solution if you want to put it there, because that tells me you have excess chromate, and that's what it's due to. So it's not a significant piece of information, but it says lead is present. And I I automatically wrote medium down, even if it would have been a small amount, I would have written medium because all knowns contain what? Make them up to contain medium amounts. Right? So if I say that looks like a trace, you can say appears like a trace of the instructor, but really it should have been a medium because that's how the sample was prepared originally. When you're getting to the unknown, you compare it to that. If it's 10 times bigger, then you say it was a principal. 10 times smaller, you put a trace in there. So this column means more when you're doing the unknown. And you can make little notes when I talk to you about it and say what I think of it. If I don't say anything, it must look okay. So I don't have, I save my breath and everything. It looks okay, I don't say anything. People say, don't you ever say it looks great? I said, no. My wife always, how come? I thought, oh, well, that's what I expect. I don't expect good stuff. I tell you when it doesn't look good. Okay, the other one also, BB, this was colorless. You can put colorless if you like to write it off. And again, this would be indicative of movement. Now one of the things when you're doing your unknown, and you compare one of them that looks like a principal, and the other looks like a medium, you're going to have to decide what you're going to put on your card, because you've got two inconsistent pieces of information. My opinion didn't divide it up correctly. And notice the other thing when you're doing that comparison, the assumption is you did things right the first time when you did your known, and you did things right the second time when you did your unknown. You messed up something and didn't get it hot enough when you did your known, but did when you did your unknown, you might get more precipitate, but it would still be a medium, or vice versa.
What qualifies it as a principal again?
What?
What qualifies it as a principal again?
Well, if I say those look okay, or I don't say much, these would be medium amounts. So your principal, when you do your unknown, would be 10 times that.
Okay.
The big problem you have is I say that looks really small for a medium.
And then it'd be
and
a
then
trace.
you get the same amount when you do your unknown. The question is, did you have a medium as you did before, or is it really a trace because you did it right the second time through? And as with anything, the more times you do it, the better you get at it. So the second time through, you usually get better results than the first time through. Okay, so now I've got my precipitate. I'm going to procedure 4. It says add 4 drops of 15 molar ammonia. This is another one of those where the cap should always be left loose. Otherwise, it starts dripping. And speaking of that, if you're working at the sink and you see smell all sorts of ammonia or HCl fumes, and you see fumes coming out of the sink, start tightening up the caps, not tightening the caps, loosen the cap, and flush it with some water, just to reduce the concentration. You can come and tell me too, and that's what I'll do, but you can start the process, and there'll be less things happening. Okay, so I want to add about 4 drops, and again, this usually makes some bubbles initially, so I'll drip it into the sink. Okay, those are good drops. Okay. Mix it. Oh, look at that, a black precipitate.
Ew.
Now, I'm not quite sure whether the pellet really broke up enough to precipitate pellet, so I'm just going to get my stirring rod, clean it a little bit, and stir it up to make sure. This is my dirty stirring rod. I really shouldn't put it here, but I'm almost done, so I don't think I need to stir it again. Now I want to centrifuge it. Here's my counterbalance. All it has is water and sulfuric acid. No precipitate. don't think the old centrifuges have a little latch like this that they've broken off a long time ago. It has a little plastic thing that sticks up, so you just have to press on the latch to loosen the lid. I think they used to have that on the other centrifuges, but the locking latch has broken off over the years. Okay, I've definitely got a black precipitate. Put my counterbalance over here, right? Like I said, take a second to fill in my table. So here I used the precipitate from tube. E2. Oops, I'm sorry, I'm doing procedure 4. That's my procedure. Okay, so here I'm doing 4, and I'll call it A. And I use the precipitate from 2. And I added ammonia. You can put the concentrations down if you want, but that doesn't really tell you that much, and you have your book when you need to know the concentration. On a quiz, I'm not going to say, did you use 2 molar or 3 molar or anything like that. I'll ask you, what reagent did you use? If you said ammonia, I'll be happy. You said, if you're talking about this stuff, you said HCl, I'm either unhappy or neither happy nor unhappy, but you'll be unhappy when you see your X. Okay. So this is one of the things you can look at. And I got a black precipitate, and that tells me I do have mercury. Or I did have mercury because I've converted it to something else now. But what we're talking about here are the ions that are present in the original solution that you started. And again, since this is a known, I'd write medium. If this was the unknown, I'd compare it to this precipitate. So I did get a black precipitate. Now your book says gray to black. What? I just keep saying black, and the book says gray to black. What would make it gray? White plus black. You knew that from kindergarten, right? So white is black, and it looks gray, and color is bad. Okay, so you have some white impurities in there. That's why it's gray. What white impurities could you have? Well, maybe you didn't dissolve all the silver chloride, which is white. White silver chloride plus the black will make it look gray. But we're going to check for completeness in just a minute. If the gray color fades away and goes to the black, in other words, I guess the white color fades away and it goes more black, then you know you didn't get all the silver chloride reacted the first time. Okay? The other thing is lead 2 chloride. Didn't wash away all your lead 2 chloride. Then the lead 2 chloride stays in there, and when you have ammonia added to it, it makes lead 2 hydroxide, which is a white precipitate. And that, when you add more ammonia, is not going to go away. So it could be a lead contamination that was converted to something else that made the gray color, or it could be the silver chloride contamination, which you can still check. But no matter what, if it's gray, there's some contamination in there. There's still mercury because you can't get gray without having some black there. But if you get a gray precipitate, sometimes the amount will not be too useful in deciding how much you have when you're trying to decide whether it's principal, medium, or trace. Okay. So first of all, I need the decantate. I get another clean test tube. Boy, these things cycle off faster and faster. I'm not talking that slowly. Okay. So I'm going to centrifuge. Decant, sorry. Centrifuge. Okay. To save time, I already know that this black precipitate is really fine. It's going to try to go over. So I'm going to use my pipette to separate them. And I use this to divide my mercury to the lead sample up, so I do have to clean this out.